In this problem we are to divide integers. You may note that this notation, 15 divided by 5, means the same thing as if you were to write the number 15 and then use a division symbol and then write the number 5. Likewise, if you picked another problem, negative 15 divided by negative 5, that problem could be written as negative 15, and then instead of a fraction or division bar here, you could think of it as you'd write the division symbol that looks like this, and then negative 5. And then the following video will show one way how to divide integers if it was given in this notation. In this video I want to use the chip model to divide integers. For example, how would you take 15 and divide by 5? So in this division problem, you can think of 15 divided by 5 is how many copies of 5 are there in 15? Or you could think of it as how many times would you have to add the number of 5 to get 15? So I'm going to start by making 15 positive chips, since the number 15 is positive. And to give you a hint how to draw this, because my divisor is 5, when you go to write your 15 positive chips, you may want to group them in groups of 5. 1, 2, 3, 4, 5. Here's 5 more. That makes 10, 11, 12, 13, 14, 15. So if you count them, I have 15 positive chips. And since each copy size is 5, and this is exactly what I used to make up my 15, I need to now count the number of copies that I had to make to reach my goal. So here's my original 15, and if you circle the number of copies, here's my first copy of 5. And if you add that to my second copy of 5, and then you were to add that a third time to my third copy of 5, what we have is 1, 2, 3 copies of 5. And if you took 5 and added to 5 and added to 5, you would get 15. So you can think of division as a repeated addition problem. How many times do you have to add 5 to get to 15? Well, we had to add 5 3 times to get 15, so 15 divided by 5 is 3, simply because there are 3 copies of 5 in 15. So the number of copies was 3, and it's the answer to our problem. So one way to write the division problem was shown up here. 15 divided by 5 was our original problem. We figured out that there were 3 copies of 5 in 15, meaning that you'd have to add 5 3 times to get 15. But sometimes the problem is not written with a division symbol. It is written vertically with a fraction bar here, 15 divided by 5, and that's also just another way of saying that you have 15 things and you want to make several copies of 5 to make up those 15 things, and if you did so, you'd have to have 3 copies of those 5 things to make 15. Another quick example of dividing integers would be if we took the last example and simply said we had negative 15 divided by negative 5, and the explanation would be almost exactly the same. Instead of asking how many copies of 5 there are in 15, we would be asking how many copies of negative 5 are in negative 15. My copy size would be negative 5, so I want 5 negative chips. And I need to know how many copies of negative 5 there are in negative 15. So I need to count 15 negative chips, but since my copy size is negative 5, I will organize my 15 negative chips in rows of 5. So here would be 1, 2, 3, 4, 5 negative chips. I'll put another 5, 6, 7, 8, 9, 10, and then another 5 makes 11, 12, 13, 14, 15. Now what I need to do is take those 15 chips, for which I arrange them into rows of 5 negative chips, and circle the number of copies it took to reach my goal. My first copy gave me negative 5. You could think of that as the number negative 5. And to that I added my second row of negative 5. So here's my second copy, and you can think of it as we added another negative 5 to the problem. And then here's my third row of negative 5, and you can think of that as we added another negative 5 to the problem, giving me that if you added negative 5 3 times, you get 15 negative chips. So negative 5 plus negative 5 plus negative 5 is negative 15. So you can think of division as repeated addition. How many times would I have to add negative 5 to get negative 15? And the answer is you'd have to add negative 5 once, twice, 3 times to get to negative 15. So as a math equation, you could say that negative 15 divided by negative 5 is equal to 3 because it took 3 copies to make negative 15. But remember that sometimes the math problem is written vertically using a division or fraction bar here, negative 15 divided by negative 5, in which case the answer would still be 3. I'd like to do one example where my dividend and copy size are different in sign, and it doesn't matter which one's positive and which one's negative. I'll make up a problem where my dividend is positive 15, and I want my copy size to be, say, negative 5. So I would be taking 15 and dividing by negative 5. And you may think of this as how many copies of negative 5 are there in the number 15? I'll start by looking at my copy size. My copy size is 5, but it's negative 5, so I would use 5 negative chips. So I'm going to use the idea that I'm dividing by 5 to tell me that when I write my 15 positive chips, I'm going to organize them in rows of 5, but they are indeed positive, so I'd have my first row of 5 positive chips, there's 5, and then if I had another row of 5 positive chips, 6, 7, 8, 9, 10, and finally a third row would give me 11, 12, 13, 14, 15. And the question is, how many of the copies of 5 negative chips will I have to write down to make 15 positives? And because this is impossible, I'll never have the right amount of negative chips to make a positive group of chips because they're different in sign. So what I'm going to do instead is I'm going to find the number of chips that make the number of chips equal, disregarding what sign they are, and then I'll take the opposite of that answer in this column. So to get the number of chips to be equal, disregarding sign, I want 15 chips, and I'm going to use several rows of 5, so it took one row of 5 to make 5. My second row of 5 would make 10, and my third row of 5 would make 15. So I'm going to count the number of copies it would take to make the number of chips equal. Disregarding sign, this was one row, or one copy. My second row was a second copy, and my third row was a third copy. So it takes 3 copies of 5 things to make 15 things. But the fact that I used negative chips and I'm supposed to obtain positive chips, you can think of it as I used the opposite sign, chips, in the problem. So I must take the opposite of the answer. And this is what step 2 says, is take the opposite of that. Since this is 3, I am to take the opposite of 3, which would be negative 3. Then in symbolic form, we started with 15, and we were to divide it by negative 5, and the result was, in the end, negative 3, not forgetting that you could use this notation to denote division as well, and 15 divided by negative 5 written this way, of course, would still give you negative 3.